I am live, according to the app. Well, I can't tell from my phone yet, so let's see. Live. Okay. Views, followers. Can I get a link to share with people? All right. Anyway, I'm gonna check one last spot. PP. Absolutely.
Hold on.
Channel. Okay, yeah, I'm definitely live. Let's do this later. All right, let's just post this on Twitter, and I'm live. Hey, and now after a rocky start, let's get started. Today, the app that we're going to make is on geeksforgeeks.org. It's called Full Screen OpenCV GTK application in C++ running on a Raspberry Pi. It was last updated in May of 2019, but it's September of 2021, and not only have the instructions fallen out of sync with the GitHub that they linked to, but overall, well, let's read this a little bit and then we'll get to the problems I have with it. Introduction. OpenCV, C++, OpenCV, and GTK are a nice triplet to build applications that run on a Raspberry Pi. I don't know why they always use Raspberry Pi. Like, in general. In this tutorial, they actually show you at the bottom how to set it up so that the app starts on boot, which is a nice touch. But most of the times you can just target Ubuntu or Debian. Anyway, taking images from the camera, process them and display them, and have an unlimited user interface. In this article, there's no author. I will show you a naive path to display camera captures to a full screen window. In a second article, I will mend some of the shortcomings of this too simple method. I hope these two articles can help you through the boring problems you need to solve before reaching the place where you can have fun. I assume that you know about coding, but you're not familiar with C++, GTK, or OpenCV. Programming language, windowing program, camera processing. This was my case when I started this little project, and I spent a huge amount of time discovering the specifics of this rich language and its dependencies. It's not a C++ tutorial. I only name the concepts and provide links to their explanations. Here you will find the project sources. The master branch shows only the very first step of this tutorial. Further steps in the branches, step 1, step 2, etc. To have the full version, you can check out the last step or the last release, which we've done over here. Let's this build, which has, or not in build, in source. So we have CPP, HPP, and res files. Anyway, an important element is to be able to build and test your project in your preferred desktop computer or notebook. Raspberry Pi is meant to be an embedded system platform. It is an amazing one, but has not the right keyboard, mouse, monitor, or amount of memory required to be comfortable as a development tool. I'm using the following technical steps. Raspberry Pi. CMake. This is the needed ingredient to make your code buildable on most of the platforms. Oh, I got a follower. Thanks, Judge Judy Slayer. Anyway, CMake. This is the needed ingredient to make your code buildable on most of the platforms. It also exports your project to Xcode, Visual Studio, Eclipse, and a long list of others, so you will be able to choose your preferred IDE. Ubuntu, C++, it's faster. In coming tutorials, we'll get more into how much faster C++ is than a Python method. OPENCV, you know, everyone knows, and GTK which is the C++ oriented port of GTK. Although OPENCV lets you display images, it's somewhat limited when interacting with the user. Being easily compatible, GTK are a great complement for building real user interfaces around computer vision applications. Okay, so then they talk about setting up your development environment. And we're going to skip that Xcode stuff because that's Mac. And we are installing on Linux. Development environment for Linux, Debian. So let's look over here. There's this thing called a Docker file. And if you don't know, it's essentially like you specify in this from line of an image that you want to use. And then you can essentially rebuild that operating system after running all the following stuff on the command line. You know, like stuff you'd normally install and whatnot. And so we're going to walk through this, but the main takeaway is that I almost had to throw all of this code out and just Google online for a working set of like configurations to accurately install OpenCV. There was the GTK dependencies. So this works right now, I guess. And they don't really specify which one they're using. Anyway, to write this part, my initial intention after installing a fresh Ubuntu distribution was to set up any well-known IDE and click around until I could compile, debug, and run the project. Boy, was I not naive. Several days later, I discarded CLion because it was a paying application. Well, yeah, why would you ever pay for an application? Come on. I had unsuccessfully tried code blocks, also a bad idea. Eclipse, boring. Lost my patience before trying Qt Builder. What? Oh, is this an ad for an IDE or something? Anyway, Unix is an IDE. Yeah, bro. Yes. Anyway, we're going to use Visual Studio Code. We're going to need apt-get, which is part of Ubuntu. We're going to need package config. So as you can see, they're saying run these lines, whereas in our Docker file, let's see, we're looking for package config. Let's see. I had spent like 2 days. I wanted to do this tutorial on Sunday, and it is now Wednesday. Just because I was trying to get the Docker file to work. Let's find package config. There it is. All right, we'll also need CMake right there. Get these required. So like I had this. Can't speak to whether it was good or not, but anyway, all right. This command, so all these are chained, the and ands. right? Oop. That makes this one big command. And essentially this pulls all the dependencies, even Python, newest version. Then we download OpenCV and we build it from the source. And yeah, so yeah, kind of what this goes through. I think I run these sometimes. Anyway, yeah. And essentially you check if you have OpenCV, and then you install this, which didn't exactly work in our version. Then you check if it exists, then you install git, and okay. So let's look at our Docker file. We have from Ubuntu. This was something I found because I was getting an error setting the time zone programmatically when building a Docker. Sort of credited this this file here. There are variants to it though. Anyway, we changed our working directory to opt build. We picked the newest version of OpenCV and we build it. Blammo. Then down here, we install git. Then to install this package, we need all of these. We can probably delete that duplicate line. Then this allows us here. The commands copy your files into the specified directory in the image and set that as the working directory. This allows us to edit our code outside of the Docker and then run it inside the Docker. Anyway, and then we open into Bash. That's the setup. And so down here, or not even down here, I wrote this little build script. We named the machine CV GTK for computer vision and GTK. And this isn't a complicated command, but the run command, there's a little more to it. Essentially, this stuff allows you to forward a screen from the Docker because we're doing camera work and a user interface. This is a shortcut to bring our working directory and place it at /user source in the Docker itself. All right. So what's next? A single window application. In this first step, we make a very simple single window application using CMake, configure the project, and GTK to display windows. Source code is available here. Configure the project with CMake. This is the CMake list test that goes in the source folder. So let's take a look. Oh, we got that. Cool. And I compared these. These are pretty much the same. But let's just take a look at it. I'm not too familiar with CMake. So yeah, I assume this is. Check for that you have a required minimum version, or else you throw a fatal error. Project name and current version. RASCAM, I guess, is our project name. Anyway, enable warnings. This sets our standard. Creates compile commands.json used by some editors for code completion. Okay, cool. Must use GNU install dirs to install libraries into correct locations on all platforms. Okay. Package config is used to locate header and files for dependencies. We had to install that earlier. Anyway, we check for 3.0, link directories and include directories. Yeah, like it says, it defines these variables. Cool, yeah, to kind of like set up the path pretty nicely. Anyway, OpenCV, compile, name of our app, which is different than the name of our project, all the files that we need to compile, and the folder with the headers, and link these files with GTK and OpenCV. There was an Apple portion here that I commented out. Anyway, that's a cool makefile. Let's keep going. This kind of goes over just what this does. Let's read it exhaustively, because we might learn something that we didn't kind of intuit from looking at the file itself, right? It's always important. And all right, just flipping windows here. CMake minimum required requires a minimum version of CMake. This allows you do confidently use the features existing in a specified version or show an explicit error message if installed version is too old. Okay, I'm not sure that was worded correctly or if I just read that irregularly, but yeah, specifies a minimum version. Anyway, project declares the name of the global project and specifies the current version and lists the languages that we are using, namely C++. Historically, the extension for C++ was .c++, but in some contexts, there's a problem with pluses. They switch to CPP or CXX. CXX means C++. In CMake, CXX means C++. I guess because X's are almost plus signs. Set CMake CXX. That's a few flags that are appropriate for modern C. Okay, and then they skip this. And they skip that. Anyway, find package config, links to the package config command so we can use it later on. Cool. Package check module GTKMM-3.0 does the same as executing package config GTKMM-3.0 in the terminal. Try it if you wish. Okay. Then copies each section of the answer into the variable prefixed with specified GTKMM. Therefore, after the command, hello, I'm scrolling. Hold a lot. Anyway, here we were. Therefore, after this command, we have three variable named GTKMM library dirs, include dirs, libraries. Interesting. Then we declare a target. One project can have multiple targets. In general, targets comprise executables or libraries which are defined by calling add executable or add library, and which can have many properties set. See distinction between a target and a command. As this is a single target project, it is perfectly convenient to define the target directly in the main CMake list.txt. List the source files to compile to create the target. Are we adding executable? Yes, we're adding an executable. Target include directories, set the list of folders to look, the files referred in sources as include ... Okay. That's the list of folders, where to look for the files referred in sources as includes. Okay, whatever. Target link libraries. That's the list of libraries of the linker. That's the link, right? Our GTKMM, our OpenCV libraries. And now we get to the application. My throat is a little sore. I'm gonna stop streaming. But I think that was a good first run. Get to the setup.